Let's start with inverse trigonometric functions. First, we are going to see that how do we reach this in inverse trigonometry. Okay, so let's make a triangle. Let's say this side is 1. Now, as we know that in a right angle triangle, okay, this is a right angle triangle, the perpendicular square plus base square, in trigonometry we learn this, p square plus b square is h square, where h is the hypotenuse. So this is 1 in this case, and there will be p square plus b square, let's say. Okay, and this angle is y. This angle will be 90 minus y. Okay, because it's a right angle triangle, sum of the angles of a triangle should be 180. That's why. Now, this is y, this let's say x, and this is let's say z. Okay, so x square plus z square is equals to 1. Now, x should be less than 1, of course, and z should be less than 1 in this case, because these two, the square of these two will make 1, so they should be less than 1. Now, we are clear in this, okay? And of course, x should be greater than minus 1 because it is a side, but we are going to see that. Now, sine of y. What is sine of y? What do we learn in trigonometry? Sine of y. The perpendicular upon hypotenuse. Perpendicular is x, hypotenuse is 1, so this will be x. Okay. Now, what do we do in inverse trigonometry? We take inverse of both sides. So, inverse, sine inverse of sine y is equals to sine inverse of x. Okay. Now, sine inverse of sine y, we take that sine and sine inverse will cancel each other. So, that way, you can have y as sine inverse x. Now, there's y. This is an angle. And this sine inverse x. Now, these two are not multiplied. You have to keep that in mind. Okay. Now, x is less than 1. So, here we can define the domain of y. How? Because x would be less than 1. And of course, x cannot be greater than x cannot be less than minus 1. So that will be your domain. But it can be equal to 1 and minus 1 because y can be 90 degree because it's an angle which is inside a right angle triangle. So it can be 90 degrees. So that's why x can be equals to 1. So this is the domain for y equals to sine inverse x. Okay. Now range. How do we calculate range? This can be between minus 90 and this y can be between minus 90 and 90 degree. Why is that? Because it's an angle. Now minus 90 will depend on this direction. Okay. But sine inverse x, when sine of y is x, you put x is equals to minus 1, you will get sine y is equals to minus 90 degrees. Or any angle, but we will take the smallest angle. Okay. Because we are talking about the range. Range cannot be larger. Okay, it will repeat again and again. So that's why. Now we are going to see the principal values and domains, okay, of ITFs, inverse trigonometric or circular functions. Okay, so the topic is principal values. I am going to make a table so that you can remember it in exam. Table learning is fast. So principal values and domains of these functions. Okay. Now, first of all, we have the function sine inverse x. Sine inverse x. Okay. Y is equals to sine inverse x. The domain for this is x is between minus 1 and 1. And range will be minus pi by 2. Range is for y and domain is for x. Okay. You have to remember this. Because it's easy. Okay. Y we are talking about the output value. So, output will be range and domain is input. And in input, we are taking x and we are doing sine inverse of x. This is a function of x, okay? Similarly, you have cos inverse x. All the 6 inverse trigonometric functions, their inverse can exist, okay? So, cos inverse x, domain is again the same. And range will be different because cos of pi is minus 1. So, that's why 0 to pi and cos of 0 is 1, okay? You can remember this by minus pi by 2. Minus 1, 1, pi by 2. 0, 1, pi, minus 1. Cos of pi is minus 1. Okay, cos of 0 is 1. You can define similarly tan inverse x. Tan inverse x, the domain is R. You can include anything, but range is same as sin inverse x except the equal sign, because tan of pi by 2 does not exist. So that's why you cannot take pi by 2 as the input. Okay, tan of pi by 2 does not exist, tan of minus pi by 2 also does not exist. So that's why we ignore the equal to sign which we include in sin inverse x. Again, cosec inverse x, the range is again x is except the sin inverse x. Okay, so x will be less than equals to minus 1 or x is greater than equals to 1. Okay, so this is just the opposite of sin inverse x, but we are including minus 1 and 1. So that's the difference, but cosec inverse x is excluding sin inverse x. Okay, you can remember it like that. Minus pi by 2, again that will be same because the internal limits are same. So y and pi by 2. But in this case, y is not equals to 0. Because when y is equals to 0, cosec of 0 is not defined. Because cosec of 0 is, cosec of 0 is sine of 0, 1 upon sine 0. And 1 upon 0 is not defined. Okay, so that's why we ignore y not equals to 0. Okay, now again the next function is cot inverse x, or let's see first the sec inverse x, because then it will be easy to remember. Sec inverse x is again the same, x is less than equals to minus 1 or x is greater than equals to 1. Why is that? Because sin inverse and cos inverse they share the same domain. So cosec inverse and sec inverse, what are they? Cosec theta is 1 upon sin theta, sec theta is 1 upon cos theta. So that's why if you are doing for cosec inverse the left behind of sin inverse, then you will do for sec inverse the left behind of cos inverse, and that's the same because their domain are same. That's why there is also, but this will be different because 0 to pi, the range are different for sin inverse and cos inverse. Again, y is not equals to what angle? Pi by 2, because cos of pi by 2 is 0. In this case, sin of 0 is 0. In this case, cos of pi by 2 is 0. And second, the cosec are the 1 upon sin and 1 upon cosec. So that's why we eliminate these 2 points. Again, we will move on to cot inverse x. For cot inverse x, the domain will be again just like the tan inverse x. Okay, tan and cot are the opposite of each other. That's why. But the range will be 0 to pi. Why is that? Because tan inverse, sine comes in numerator. So that's why you can remember this, because sine and tan share the same. Okay, same thing. Sine is also this and tan is also this, except the pi by 2 and minus pi by 2 points, because there tan and cot are not defined. Now this will be just like this except the 0 and pi points, because at that point cot is not defined. Okay, so that's why these two are same. I mean these two are nearly same except the equal sign. Now we'll move on to some property. This was property 1. Now we'll move on to property 2. Property 2. Let's say sine inverse, what I just described earlier to prove that y is equals to sine inverse. This is equals to x, not everywhere, only in the domain. Okay, because this thing is domain now. So x will be from minus pi by 2 to pi by 2. In this domain only you can apply this thing. Okay, if x is in between minus pi by 2 and pi by 2. If x is pi, then you cannot apply this, because sine of 0, well, in case of pi you can apply this, but in case of like 3 pi by 4 or something like that, you cannot apply this because it will give negative results and other results. Okay, now the second property, this is the first property. Second property will be about cos inverse. Of course, cos inverse cos x is x, all of them are x, only the domain is different. Domain is just like the domain, the range of cos inverse x and sin inverse x. Now we'll move on to the third property. These two are just similar. You can see the relation. Okay, let's just see. You remember this. Okay, now sin inverse sin x is equals to x. this is the domain for x. Whereas in this case, this is the range for sine inverse x. That means the domain of this, the range of this, range defines this, and when you take sine inverse of sine x, then this range will become domain. Okay, it's just as simple as that. Okay, now we'll move on to the third property, that is about tan inverse tan x. Third property, tan inverse tan x, it will be again x. The light has gone off, just a second. Okay, tan inverse tan x will be x if x is between what? Again, its range, which was minus pi by 2 to plus pi by 2. Okay, this is the range for tan inverse x. So that's why its domain will be, the tan inverse tan x is equals to x, the domain will be minus pi by 2 to pi by 2, excluding both the points. Okay, now the fourth property is cot inverse cot x. That is also x if again the range, so 0 to pi. Fifth property is sec inverse sec x. That will be x if x is what? 0 to pi except a point which was pi by 2. Okay, now cosec inverse x, same as all the above. Cosec x is equals to x if x is between minus pi by 2 to plus pi by 2 except x is 0. Okay, for that case you cannot include, because cosec x is not, cosec 0 is not defined. Now the third set of property we are going to deal with, that is sine inverse of minus x and cos inverse of minus x. What are these terms? Third property set, first is sine inverse of minus x. What is sine inverse of minus x? Sine inverse x minus of sine inverse x. The domain will again remain minus 1 to 1. Why is that? Because now you are dealing with sine inverse of x. In that case, x will follow the original domain. Okay, the original domain was minus 1 to 1. You can see it here, that the original domain was minus 1 to 1. Okay, it's here. Original domain for cos is minus 1 to 1. So both will be same, cos inverse x and sine inverse x. Okay, now we are going to move. Okay, now sine inverse of minus x is, this is a property. Okay, this is not a minus sign. Sine inverse of minus x is minus sine inverse x, again if x is in between minus 1 to 1. For cos inverse x, we have cos inverse minus x, we have a different case. It's pi minus cos inverse x, but the x is between minus 1 and 1, because the domain is always the same, minus 1 to 1, minus 1 to 1 for sine inverse, for cos inverse. Okay, this is the same, but these two might be different, and they are different actually. Now we will move on to tan inverse x. Tan inverse of x is minus tan inverse of x, just like sine inverse x, because they share the same range except the intermediate points. Here x will belong to R, because this is the domain for tan inverse x. Similarly, for cot inverse x, now you will see the relation between cot inverse and minus cot inverse. Okay, cot inverse minus x and cos inverse minus x. This is cot inverse x, pi minus cot inverse x. Now can you see this? Pi minus cos inverse x, pi minus cot inverse x, minus tan inverse x, minus sin inverse x. Okay, they share the same range, and that's why their functions will give same values at minus x. They share the same range except the points, and I will not talk about that. We can say that they share, similar range. So that's why their some cos inverse minus x and cot inverse minus x are same types. Okay, but the domain will be again R, because the domain for cot inverse is R. Okay, we are dealing with cot inverse, that's why. Now we'll move on to fourth set of property, which is the addition of sine inverse and cos inverse. The first property, sine inverse x plus cos inverse x is equals to pi by 2. Again, the domain will be -1 to 1. Why? Because we are dealing with sine inverse and cos inverse here. So, sine inverse and cos inverse, the x should be between -1 and 1. And this property is a very good one. Like, you can say that example is sine inverse half plus cos inverse half. What will this be equal to? Now you don't have to calculate that sine inverse half is pi by 6 or something, and cos inverse half is pi by 3. So their sum will be pi by 6 plus pi by 3. That will be pi by 2. But you can just directly apply this property and you will get the pi by 2 answer. Okay. This is also mathematically correct in that case, pi by 6 plus pi by 3. But we'll use this because in some cases you might have to deal with 1 minus this and 1 by root 2 and 1 minus 1 by root 2. Now their sum is, 1 by root 2 and 1 by root 2. So that will be again pi by 2. Okay. Sum like 1 by root 3, 1 by root 3. That will be again pi by 2. So that's one. Okay. Now the second property. Second property will be with tan inverse and cot inverse, of course. So tan inverse x plus, because they share the same domain. That's why their sum is pi by 2. Again, their sum is also pi by 2 if x is in the domain of both of them. Third point, that will be about cosec inverse and sec inverse. Because they share the same domain. Again, which is that x is greater than equals to 1 and x is less than equals to -1, and x or you can say just the mod x is greater than 1. Okay, this is the domain. This can also be written as mod x is greater than equals to 1. Okay, mod x, the graph for mod x is this and 1 is there. So this is the domain. After this, and after this is the domain, except minus 1 to 1.